Here on BBC One now, Patrick Moore is chasing asteroids.
Our Earth had been the abode of life now for a very long time, but could we be on a collision course with an asteroid or a comet? Good evening. We now know our Earth has been under a constant barrage from space for a very long time now, but is there any chance of a really major impact with an asteroid or a comet? And we're going to spend 2 programs discussing this. It's a fascinating subject and one of great importance to us. But first of all, a few news notes, and let's look back temporarily to the eclipse of last month. You may remember that in 1999, I was with Peter Catamole in Cornwall, sitting under an umbrella and saying nasty things about the rain. Well, I wish I'd been with Peter this time in Zimbabwe. We had a good view from there. And here's one of his pictures, a rather lovely scene. Also in Zimbabwe was Martin Moberly, and he took this picture, which shows the corona very well. The pearly mist stretching out from the sun at a very high temperature. There's not much actual heat there. And then, what about the view from space, from Soho? From Soho comes this amazing picture. You can see there the structure of the corona. Coronagraphs, of course, can show the corona at any time, but here on Earth we have to wait for the moon to block out the sun. And this lovely picture by Douglas Arnold does show the corona very well. What he's done is to take a series of colour filters and put them together, and there you can see the structure of the corona in that lovely picture. And also one of Douglas's usual time-lapse pictures showing the progress of the eclipse period and a rather surprised bird. And from space, a picture from the EUMETSAT. And here we see the passage across the Earth, the dark umbra in the middle, and to either side the area of penumbra where the eclipse is only a partial. To see the corona, the eclipse must be total. From the Victoria Falls it wasn't. The sun was 80% obscured, and that wasn't enough. You've got to have the entire thing to see the corona. But remember, if you're not in the zone of totality, you won't see the lovely sights, Baily's beads, the corona, and the prominences. The eclipse must be total. If you miss this one, well, there's another from Africa again and Australia in December 2002. And if you stay in Britain, well, there's always 2090. Look low in the south, late at night, and there you will see the planet Mars, appearing as a very bright red star, rather more than 40 million miles away from us. And telescopes, of course, do show the white polar caps, the dark areas, and the red deserts. But that picture comes from the Mars Global Surveyor probe, showing the cloud structures there, and of course, far more detail than you can see from the Earth. But another probe, Odyssey, is on its way to Mars now, and it'll get there in October. It's not going to land. This is an orbiter, and should send back more spectacular pictures of the Martian surface. And of course, we'll follow that very carefully in the sky at night. August is the month of the Perseid meteors. We go to the debris of Comet Swift-Tuttle, and we should have a really good shower, particularly as this month the moon's out of the way. The shower peaks around August the 12th, and the moon will not be obtrusive at all. Remember, these meteors radiate from particular points in the sky, and these come from Perseus, hence the name the Perseids. And they can be spectacular, but are they dangerous? People ask me that. The answer is no, they're not. They're a sand grain size, and they evaporate at more than 40 miles above the ground level, so they're quite harmless. But now and then, we do meet a larger body that lands intact, and we even meet a quaker. And these meteorites come from the asteroid belt and are not connected with ordinary shooting stars. And here's a typical meteorite, a bit of a Barwell meteorite that landed in Leicestershire on Christmas Eve 1965. But that's a small one. The holder of the heavyweight record is still lying where it fell in prehistoric times at Hobo West in southern Africa. And there it is, the Fontaine Meteorite at Hobo West, and that weighs more than 60 tons. The Hobo West meteorite is a large thing and could have caused a great deal of damage had it fallen in an inhabited area. So what are the dangers? Our solar system is made up of one star, the Sun, the principal planets, their satellites, and various smaller bodies that do whirl around, comets, asteroids, and meteoroids. And we know they can strike planets. In fact, in 1994, the giant planet Jupiter was struck by a comet, Shoemaker-Levy 9, which broke up and caused great turmoil in the planet's atmosphere. And Earth-sized fireballs were created by the impact. And some spectacular pictures were obtained. We can see here parts of the comet, You can see the Great Red Spot also. There's the Great Red Spot. And those black areas there indicate the places where fragments of comet Shoemaker-Levy 9 hit. But of course, Jupiter's atmosphere is gaseous, no solid surface visible there, and therefore no permanent effects. But what about our moon? Now, the moon is covered with impact craters. There's one Copernicus. The entire surface is pockmarked with them. And, of course, the moon had no atmosphere, therefore there's no erosion, and those craters stay for very long periods. On Earth, we do have erosion, and we have impact craters too, but they're very largely worn away, and therefore we're not so covered as the moon. But look at these clear water lakes in Canada, nearly 300 million years old. Rather younger, but still ancient, is the Wolf Creek crater in Australia. I flew over that a little while ago. It's quite spectacular. And then, 49,000 years ago, Meteor crater in Arizona. It really should be Meteorite crater, another picture I took a long time ago. And younger still, only a few thousand years old, the Henbury craters, also in Australia, coming out of modern times. And therefore, what about recent impacts? Well, the famous one in June 1908. Something hit Tunguska in Siberia and blew pine trees flat over a very wide area. And these pine trees, they looked like matchsticks. In fact, the entire area was devastated, although no one got there for some time. No crater there, but certainly, had they hit a city, the death roll would have been colossal. So after all, if that can happen, it could happen again, then we are not entirely safe. And to say more about this, I'm joined now by two experts, Jay Tate of Space Guard and Lembit Opik MP, who've been paying great attention to this. Lembit, of course, I knew your grandfather, Ernst Opik, very well indeed. How did you become interested in this particular topic?
Well, it was because of him. He worked in Armagh Observatory, as you did yourself, and every weekend I'd go to his house in Bangor, Northern Ireland, and peruse the endless library of books that he had on astronomy. So while others were reading Jack and Jill, I was reading books about the oscillating universe.
Well, what about you, Jay? How did you come into this?
Well, my interest started really with Shoemaker-Levy 9, which you mentioned earlier. We actually saw the spots on Jupiter through a small amateur telescope in the States. And it then occurred to me, why not find out what's being done about the potential hazard to the Earth?
Shoemaker-Levy 9 certainly made us alive to the dangers, but that, of course, was a comet, or bits of a comet, and I think the main danger probably comes from asteroids. So let's have a look, shall we, at a plan of the solar system. You can see there the gap between the paths of Mars and Jupiter, and most of the main belt asteroids stay there. The Centaurs and the Trans-Plutonians are so far away, they are no threat at all. It's the near-Earth objects, NEOs, that are the PHOs, or potentially hazardous objects. So they're the ones you've got to bother about.
That's right. So what we're concerned about are the ones that could hit the Earth in simple terms, and there's quite an objective definition for a PHO. It's any object which is larger than 150 meters and comes within 7.5 kilometers of the Earth. There are some specific categories that concern us in that way.
There are indeed the Aten, the Amors and the Apollos.
That's right, Patrick. We've got these three families. In fact, the A10s and the Apollos both have, or as families, both have orbits that cross that of the Earth. The Amors don't at the moment, but of course, with the perturbations that happen within the solar system, we could see them having Earth-crossing orbits in the future.
Obviously, we want to find out as much as we can about these things. That brings on to Eros, discovered in 1898, the first asteroid known to cross the orbit of Mars, although not that of the Earth. And I was immensely impressed by the near Shoemaker probe that actually landed there and sent back amazing pictures and certainly told us what Eros is like.
Well, the near Shoemaker spacecraft was in orbit around Eros for about a year, taking very, very detailed close-up photographs. And it showed Eros to be a solid lump of rock, but covered in craters and covered in dust and dirt.
And of course small and less than 20 miles long.
Absolutely. It's only about 33 kilometers long and it's only about 13 kilometers across. So it's almost like a peanut shape. But at the end of the near Shoemaker mission, rather than just switching off the spacecraft, they decided to try and land it. Now, this is a spacecraft not designed to land anywhere. It's designed for deep space, but they thought, hey, rather than just wasting it, let's give it a go.
Nothing to lose.
No, absolutely not. So they produced a very complicated flight plan to gently bump it down onto the ground, and it worked a dream. It worked an absolute treat. So from a spacecraft that was simply designed to orbit the asteroid, we ended up with a lander, and a lander that worked after it had hit the surface and was sending back good data.
Did they intend to do anything more after that?
Well, there was a plan. It would have been nice to light up the little engines, the little reaction motors, and just make it bounce a little bit so they could try and sample another bit of the surface. But it was decided that the data coming back from the spacecraft was so good and so valuable, it would have been too much of a risk to try that.
Eros, of course, is no threat. It's an AMOR type, therefore its orbit doesn't cross ours. But we are concerned with those that do, PHOs, potentially hazardous objects. What about the definition, Lembit?
Well, there are two definitions that matter to us here. First of all, near-Earth objects, and those are defined as anything within 0.3 astronomical units, the distance from the Earth to the Sun. From the Earth, that's somewhere just under 30 million miles. Now, the PHOs, the potentially hazardous objects, are defined equally objectively. We define those as objects greater than 150 meters in diameter and within 0.05 astronomical units. That works out at about 7.5 million kilometers. Those are the objects that, in the views of science, do present a serious threat of impact.
Well, there are plenty of them. What's the latest count?
Well, as far as potentially hazardous objects are concerned, the latest count is 272.
What's the total, do you think?
Well, it's very difficult to say. As far as the larger asteroids are concerned in near-Earth orbits, we think we found just under half. So we can certainly double the number of PHOs.
I wonder, can there be any larger ones we haven't found yet, do you think?
I think it's very possible, and we've got problems here in terms of simply tracking the objects. We've only identified a small number because we haven't been working at it all that full time. But we have to recognize that anything above about 100 meters is a pretty serious threat.
We've got to bear in mind too, haven't we, that these things are often seen on the same part of the sky as the Sun, therefore they're not easy to track.
We do have a problem because, of course, half the sky is essentially blotted out by the Sun. But, of course, as the Earth rotates or orbits around the Sun, those bits of sky do become visible. So we do have the opportunity to survey the whole of the danger area, if you like, over the course of a year.
So let's come on now then, shall we, to comets. After all, comets can be spectacular. All remember Hale-Bopp, a lovely comet, and much more spectacular than Halley's comet was. Although I think in the 834, Halley's comet cast shadows. I wasn't there myself, you understand. But comets, of course, can come from anywhere. And there are two types. They are the short period comets and the longer period comets, and they have different origins. The short period ones come from what's called the Kuiper belt.
That's right. The short period comets come, as you say, from the Edgeworth-Kuiper belt of debris that orbits the Sun roughly on the ecliptic, so on the plane of the solar system, really beyond the orbit of Neptune. So we have a large number of objects ranging in size. There is a certain amount of controversy, as you know, as to whether Pluto is simply the largest of these objects or a planet, but we needn't get into that.
No,
But the key thing about the short period comet, apart from the fact that its period is by convention less than 200 years, is that they do approach the Sun in the plane of the solar system along the ecliptic. So if you're looking for a short period comet, you know pretty much where to look. And of course, because they have short periods, we've seen an awful lot of them before. So we don't think there are that many yet to discover.
Not so with the long period comets, and they of course come from the Oort cloud, and your grandfather was concerned with that, Lembit.
That's right. In fact, my grandfather postulated the existence of that cloud of comets way, way out. We're talking about 10,000 to 100,000 astronomical units from the Earth. Of course, I could argue in a very selfish family-like way that maybe it should have been called the Lembit Opik cloud, but once again, that's for another day.
I think it probably should have been, actually. He did suggest it in the same way that Edgeworth suggested the Kuiper belt before Kuiper did.
Right, yeah.
And some people do call it the Edgeworth-Kuiper belt. But these long period comets, well, we can never predict them, of course, and we only see them once.
And there are two problems. First of all, these things have a very long orbit if they do come into the Sun at all, maybe in the order of hundreds of thousands or even millions of years, so way beyond the extent of human observation. The second problem is that they're not on the sphere of the ecliptic. The problem with these things is they form a sphere right round the solar system. So quite simply, these objects could come at us from any direction. So we'll see them once on the way in, and we might not see them at all if they're coming at us from the Sun.
On the whole, let me ask you both in turn, which do you think is the bigger threat, comets or asteroids?
I think from the minor impact side, obviously the asteroid is the major threat. But the nightmare scenario is the long period, large comet that only gives us maybe 18 months, 2 years of notice.
Would you agree with that?
Yes, I would put it quite simply that the asteroids are a more prevalent and present threat, but also more predictable and also more manageable. Meanwhile, the comets present a smaller threat, perhaps between 10 and 30% of the threat, but when they do come along, they're the mavericks, they're the wild cards, and in some ways, if anything keeps me awake at night, it's what we do about those comets.
We know these PHOs, or potentially hazardous objects, do exist, and we've found more than 270 of them now. But, Jay, you made a special study of this. How many do you think there really are?
Well, therein lies the question. As far as we're aware, for near-Earth objects, in the size range of about 1 kilometre in diameter, the estimate is somewhere between 500 and 1,500. The answer is probably in the middle somewhere. The Americans certainly like to use the low end of the scale, and others prefer the higher end of the scale, and there are good reasons for either. If we drop down in size, though, down to about the 100-metre size, we're looking at many, many, many more. We're looking at anywhere between 30,000 and 300,000.
We're giving these various estimates, but how do you make them?
Well, there's two ways. In fact, there are only two ways we can do it. Firstly, because we're only surveying very small portions of the sky at the moment, we can take the proportion of the sky we're looking at, the number of asteroids or near-Earth objects we find in that small patch, and then simply multiply that by the area of the sky, if you like. The other way, of course, is to look at the moon. Our closest neighbour, it's in pretty much the same place as we are, so really the flux of things that have hit the moon are the flux likely to hit us. Although, of course, the Earth has a slightly deeper gravity well, so we will pull in a few more.
But there's bound to be uncertainty.
There is. Jay's describing our two estimate processes, but that's exactly what they are. They're estimates. And the problem for us is it only takes one big object to hit the Earth to cause a lot of damage. The other statistic that people are both worried and entertained by is the fact that you are 750 times more likely to die as a result of an asteroid impact than to win the British National Lottery this weekend.
Probably true. On the other hand, we can make pretty good estimates now of the area of damage would be covered by objects of various sizes.
Yes, we can. Objects of around 50 metres or less are likely to explode and break up in the atmosphere without major damage to the surface. If you get to around 75 metres, you get a Tunguska-like impact, flattening trees and maybe a couple of thousand square miles. On up to 300 metres, you would destroy a continent. At 1 kilometre, you'd be having global effects. And at 10 kilometres, you'd probably be looking at global extinctions, perhaps as much as 7/10 of life on Earth.
Well, we've established, therefore, that although the chances of a major impact are slight, they are not nil. And did it happen 65 million years ago with disastrous result for the dinosaurs? Who knows? And I think when we come back next month, we'll go more into that and also discuss what we could or could not do if we saw one of these things approaching us. Is there any way we could protect ourselves? Come back this month and we'll go further into that. Lembit and Jay, thank you very much. Meanwhile, don't forget it's newsletter time. If you want a new newsletter, send your stamp address envelope to The Sky at Night, BBC TV, London W1270S, and we'll send you newsletter number 82. Also, our website, www.bbc.co.uk/Sky at Night, or tune in to CFAX page 620. Meanwhile, Mars is still there, and don't forget, August is the month of the Perseans, and we may have a very good display of shooting stars. So let's hope for clear skies. Until next month, good night.
Just a quick reminder, there's a special programme catching up with Beagle 2's Mission to Mars tomorrow night at 11:20 on BBC 2.